So the question at the point where we left our last lecture was what should be the structure definition of stack. And I was asking the question that of course we require top, and which is nothing but a node pointer, which is pointing to top of the stack essentially. But do we require the list pointer also? Now, incidentally, in this case, the implementation that we discussed, or rather that some of you proposed, is that the starting node of the linked list itself can act as the top of the stack. So that is essentially the end at which we add as well as we delete the elements. If that is the understanding, then in that case there is no point in having two pointers to the same node. One is top and other is LPTR. So maybe instead of LPTR I can just have one single pointer. This is not the case when if we had decided that the last node of the linked list was the top. We could have decided like that, and we could have made sure that the insertion and deletion always happen at the end of the linked list. Why we are not choosing? Because from the insert at end and delete at end function, you would have realized that we have to traverse the whole linked list to reach to the last node. So there are some issues. So it is much better or much easier to have a pointer to the starting of the linked list, and top itself serves the purpose, both the purposes of the top of the stack, as well as it is the LPTR, which is the list pointer. Okay, so this is what we can decide. After we decide this, after this part is done, now if I ask you the question, let's start writing the main function. What is it require for the main function? Maybe I want to take a stack. Okay, so I will say stack stck is what I want to take. Look at the declaration. I am just having stack itself is the data type now. So with this data type I am taking variable stck over here, so which is perfectly fine. Now we know that in any data structure the first function that we use is the initialize stack function. So if I say that I use the function initialize stack, what is it that needs to happen inside the initialize function? So I need to define initialize stack function. If I take stack stck, if this is I pass, the problem with this declaration is that it is passed by value. So if I say that initialize stack, and over here I will say that stck, it is passed by value. So remember that the pointer is inside the structure, but the structure itself is passed by value, right? So it's a structure we are passing, not a pointer to the structure. So it's structure we are passing, which is passed by value, and because of that, any change that so another copy of structure gets created over here, and any change that you make is made in the copy and not in the original structure. So the same problem we have faced multiple times, that to make sure that the fields inside the structure are updated, I need to pass the pointer to the structure, and this I can do by passing ampersand of stck now, which means that this is not stack but this is stack star, and I will call this as stck ptr. So what is the initialization which I need to do when stack is empty? What should I do? What is the initialization should I be doing? What does the stack contain? It contains top. So what is the initialization I am going to do in the beginning? Top equal to -1. There is no -1 over here, right? I mean it's a pointer. So top is a pointer. It's a node pointer. So what can you assign the node pointer to? It is, you can assign the default value is null. So over here you can say stck ptr, but now arrow. Remember that, because it is the pointer. stck ptr itself is the pointer. So that's why we take arrow top is equal to null. Okay, fine. So this is like initializing linked list to null, right? I mean, when we initialize this top tool, essentially the linked list is empty. That's what it means. And now I want to insert an element. So what I can do is I need to write a function which is, let's say, push function. And in the push function, I need to pass some value. Let's say I pass value 10. And I need to pass the stack pointer. So I can again pass ampersand of stc. Question is, how do I have the function declared? So now remember that in the array declaration of the push function, we had taken the declaration as status code. We are returning back status code. Why we are returning back status code? Because in the array declaration, there was a chance that the memory can become full. Is there a chance in the linked list declaration that the push function may not succeed? It may be a failure. Is there some condition like that? So I want to write a push function. So to this push function, I need to pass item type, and let's say E, and I have stack star stck ptr. So is there a case where the push function fails? Yes, even in this case, the push function will fail when malloc fails. Although it is a very rare phenomenon that malloc would fail. Essentially, what it means for malloc to fail, it means that all the memory in the heap has been allocated. Now that is kind of impossible, because if that memory requirement, if you're writing program with that kind of memory requirement, typically it is not going to work. That is, so if I write valid program with that requirement, perhaps I should not be writing that program. Number two, there could be a chance that my program has memory leak. So there is some memory which I am leaking, and maybe I am leaking in a loop. So what is happening is, just after some time, the whole memory gets basically full. Or it may not be memory leak in my program, it may be memory leak in some other program which is running in parallel, or which is running together basically. And then because of that, hash has become, sorry, the heap memory has become full. And because of that, if the heap memory has become full, then malloc will definitely fail. So the heap, because heap area becomes full, dynamic memory cannot be allocated, it can be failed. So there is a chance that malloc could fail, although a rare chance, but it could happen. So I can actually have the same declaration for the push function, which returns back the status code. And by default, I will say that status code, let's say SC, or I will call it as rate val, is equal to success. That is the default value. And now what I will try to do is, basically, even before I do this, I require a node pointer, a new node I am going to get given to allocate. So I can directly write node star, and I don't have to write struct node star, because node itself is the type now, right? You must have realized that above I have declared node itself as a type def. So node itself has the struct, node itself is the type now. So I can just say node star nptr. Okay. And now what I can do is that I can allocate a new node, because I am pushing. So I need to allocate a new node in the linked list, right? So I need to allocate a new node, which I know what I need to do, which is node star over here. Remember that now struct, instead of struct node star, it is just node star. And then I do a malloc, and I do size of, no, size of also I change it to node. It might be the case that nptr may be null, in which case essentially the malloc has failed. So if nptr is equal to null, then in that case I will say that sc is equal to failure. Okay, yeah. So in this case, SC is equal to failure. In the else part, when nptr is not null, then what all things are to happen. Now this is like, I mean, we are saying that we want to insert at the start of the linked list, and we exactly know how do we insert the node at the start of the linked list. So first thing which needs to happen is nptr arrow next, and data also has to be set. So firstly, nptr arrow data is to be set, which I will set to the value which has been given to me, which is E, item type E. And then I will set nptr arrow next, and nptr arrow next is to be set to nptr arrow next is set to top, because top is the list pointer now. So nptr arrow next is set to top. So what all things have happened? There is a list pointer. So you can imagine that we have a linked list. which is pointed to by top. So we had a linked list somewhere over here. So instead of LPTR, it is pointed to by top. And then I create another node over here, basically the first node over here. And then nptr arrow next is equal to LPTR. So you can imagine that what I'm doing over here is that I'm creating another node, calling it as nptr. Okay, and this is currently top. Basically, you can assume that this is instead of LPTR, this is top, and this is nptr node pointer, and I'm just setting nptr arrow next is equal to top. So this node will start pointing to the top pointer, which means that this node has come before this first node. So this is what I have done. But then after that, of course, I have to change the top itself. So these two things have to happen. So after I do nptr arrow next is equal to top, top itself has to change. But now can I write top directly? No. So for that, I had to write stck. There is no direct top. So I need to say stck ptr arrow top. Okay. So nptr arrow next is stck ptr arrow top, which is the field inside the stck ptr. And now this stck ptr arrow top itself has to change. Stck arrow ptr arrow top itself has to change to what? Stck underscore ptr arrow top has to change to the nptr. So the first node that I added at the start essentially is the new top. Realize that this definitely works when the top was originally null. Even if the top was originally null, in the basic case, even in that case, your nptr arrow next gets set to null now, and new top is the nptr, which means that you have just added one single node in the linked list. There's one single node, which is either you call it as nptr or top, and then the arrow next of that node is null because original value of top was null. That is what we have achieved over here. And after I do this, I will say return status code or return what is that rate file. Okay. Sure. So now this is done. Push is done. Maybe I can call this push function multiple number of times. No issues. So I have 10, I have 20, I have 30, and likewise. Okay. Now, what about pop? So for pop, again the same thing, that I want to pop out the element which I want to capture. So that is possible if I can declare in the main function, if I can declare item type, let's say some element which I want to capture, through which I want to capture. So I can say item type element. Okay. And to this pop function, I give this ampersand element. Okay. And then I just put stck over here, stck pointer over here, which has been passed. So what is the expectation? Expectation is that the top element of the stack has to be popped out. Whatever that value is to be set. Whatever is the data value is to be set to this element, which is of item type I have given. That's why we are sending the pointer, so that that value can be captured. And stck pointer, the stack pointer is being passed. Why we are not capturing the value which is being basically which is at the top of the stack as a return type? Because the pop function actually can fail, and ideally, so that's why we will require some status code to be returned back as the return value of pop. And even in linked list kind of situation, the pop function will fail when the linked list or the stack is empty, and which can anyway happen. So just to keep that facility, that I can capture status code for the given pop function. Although in this particular case, perhaps it will go through, because assuming that push are successful, pop will also be successful. So, but otherwise, I need to be careful that I should be returning back the status code. Who am I over here? I am talking as essentially someone who is writer of the, or he is the programmer of the code for pop function. So what is the code for pop function is going to look like? It returns back status code. Okay. Remember that I have not given again the definition of status code over here. If I had to give, I had to basically write over here, which I can definitely do, which is type def enum, and to that I will say failure is 0, which is fail, and success is 1, and this whole thing I am declaring as status code. Okay. So assuming that such status code definition has already been done, the pop function I can write, which returns back status code as the return type. Then it has pop. Then it has item type pointer, which is EPTR, I will say, and then I will have a stack pointer. So I have stack pointer stck underscore ptr. So what all things are required now over here in the pop function? So the first thing that is required over here is that I need to have the return type, which is status code, which is ret val. Okay, and that I will set to success. This is a default value. And the first thing I need to do is I need to check whether the pop function is going to be successful or not, and that I can easily check by checking whether top is whether the linked list is empty or the stack is empty. So I will check whether stack is empty. How do I check whether stack is empty? Either I can write a separate function checking that whether is stack empty. I can definitely write that, or I can basically say that linked list is empty. And what is the condition for linked list being empty? Top being equal to null. So again, it depends on what level of modularity that we require over here. So if I'm okay in this particular case, I will say that if stckptr arrow top is equal to null, and in which case I will say that in this particular case my ret val is going to be failure. Okay, fine. So if top is not, remember that this condition I can change also. I can change this condition by saying is stack empty. Okay, and to which I will pass stckptr. This I am adding one more level of modularity over here, which means that I am not declaring that what is the stack empty condition. Let someone else take care of it. And then over here, I will say that what I require over here in the else part is that I need to remove the element from the top of the stack, which means that the element at the top of the stack is nothing but the starting node at the linked list, for the linked list, which is currently being pointed to by the top pointer. So I know how to delete at start. Essentially, this is something similar to delete at start. So I need to take my top, and remember that stack is not empty, which means linked list is not empty. So I need to take my top to the next node. But before I do that, I need to capture the value which this particular node has. And after I take top to the next node, I need to delete this node also. And so that I need to point that node by some another name. And this can be achieved by having one extra node pointer, which I will call it as nptr. So the first thing perhaps I can do over here is that nptr is equal to stckptr arrow top. So I am essentially what I am doing is the first node is being also known by another name, which is nptr. Now it is the things are up to me. So I have a star of eptr in the contents of the element pointer which has been passed, that I can set to nptr, which is, remember that it is the first node now, arrow data. It could be stck and underscore ptr arrow top arrow data also. Okay, so I'm just reducing one level of interaction over here. And so data has been captured. Now what I can do, I can take my top to the next pointer. So for that, I have to write this complete stuff. stck underscore ptr arrow top is equal to stck underscore ptr arrow top, and just to make the meaning more clear, I can bracket this out and say that whatever this gives me the first pointer or node pointer to the first node, that node arrow next is what I want. Okay, so I want my stck underscore ptr arrow top, rather I want the top itself to become top arrow next. Actually, that is what ideally I require, but top is being accessed by stck underscore ptr arrow top, so that's why I'm using that. And after this gets done, and now the what remains is that I can free up this first node, and for that I will write over here, I will write free of nptr. Okay, so look at these four statements. What we are doing is the first node is being known with another name now, which is nptr, and I capture the data in the nptr in the first node as eptr, star of eptr, and then top has been taken to top arrow next, which is the second to the second node, and then I'm freeing the nptr. This case, of course, just like delete at start, this case also works implicitly or directly when there was a single node present. So when there was a single node present, this top equal to top arrow next makes this top equal to null, because if there is a single node present, that node arrow next is null, which means top arrow next is null. So by doing this top equal to top arrow next, essentially I'm setting implicitly top equal to null. So linked list has become empty, and that condition need not be checked independently or separately. So this happens as part of this routine code itself. Okay, we are just noting this point, although we are not putting that condition explicitly, but we are just noting that this condition is working. So we are sure that this code will work. And then finally, after this all this thing gets done, then I will say return status code. So what did I choose? Rate val. Yeah. So now what remains is basically a function like, is stack empty stck ptr. So perhaps that function I can write before I write the pop function. What does it return back? It will return back boolean. So I will say it returns back boolean, and my name of the function is stack empty, which takes stack pointer. And now I have to just check whether the value of the top. So if top is null, I have to say the answer is yes, the stack is empty. If top is not null, then answer is no. So there are two ways in which I can write this code. One way is basically this way, where I will say that, so I can have a boolean rate val is equal to, just let me just have it, and I say that if stck underscore ptr arrow top is equal to null, I will say rate val is equal to true, else I will say return val, which means stack is not empty in this case, and that's why I will say that rate val is equal to false. Okay, so this is one way, and of course I have to return back rate val. This is one way of writing this code, and I will show you one shortcut to write this code. So return rate val is definitely one way in which this code can be written. So this first letter everywhere I need to change it. Yeah. And boolean, did I declare boolean? I didn't, but then of course it is very easy to declare. I mean, if you want, you can do this over here by doing that type def enum. And now I have false and true. So false is 0, true is 1. I call this as okay. So this is done. Now this code, this is stack empty, can be written very easily. I mean, I need not write this. This could also be written by knowing that value of true is 1. Okay. So this is this we know. So this code, there is an alternate way of writing this. So uh, I will just put everything under the comment. Okay, so this is a valid code anyhow. And the alternate way is just one single line which says return. I'm just showing this because if in the book it comes like that. Actually, I'm pretty okay with if you write this kind of thing. It is very easy to understand, and there are less chances of making any mistake. But because some books might refer it like this, so it might be can be written that stck underscore ptr arrow top is equal to null. So what is this? This is a condition. So it is returning back the value of the condition. Now this condition is when this condition is true, the value 1 will be returned back, because in C language the value of true condition is 1 or positive value. So it will be mapped to true basically. We can assume that way. Okay. Yeah, otherwise, even in other languages, this is still fine, because what we are returning back essentially is the value of the condition. So typically, in languages like Pascal or in Java, this condition itself will return back what is called as true value. And if this condition is false, I mean, if stack ptr arrow top equal to null, if it is not correct, then it will return back 0, which is false basically. So the 0 and 1 will be returned back in language like C, but in other languages it will actually return back false and true. This is one single line implementation of this function. So as I said, that at least we should be able to understand what this means. That's why I have just discussed this. Otherwise, I am pretty okay, and it is much better that we write the code which is, less mistake prone. Where like this, where we are quite fine with this one. Okay. So we can do this function is stack empty. Now is stack full? If similar function that you want to write, it is little bit tricky function, because what happens is, how do I know that the linked list is full? Linked list is never full. It has already been created, which means that it is not full. So what do I mean by full? So it is more like at this point in time, if I do a malloc statement, will that fail? Is my definition of is stack full. But again, it's a dicey definition, because it might happen that when you check whether the stack is full or not, and it says that, okay, my malloc is failing. But it might happen that in the meanwhile, when you come back, some other program releases some memory from the heap, and then you actually call malloc function, basically it may become successful. So is stack full function, basically you can always say that it returns back false, because it's very difficult to check. So it says that I'm not full anytime, basically. But is stack empty is something which you definitely need to check, whether the stack is empty or stack is not empty. Okay, so with this, what we have done, and so I have done this main function over here, and maybe I can have another pop function being called over here. And now if you notice, again, this code, when you look at this code, it never says that whether this stack was implemented by using array or linked list. And this is the point I was making, that even if we have created this structure definition in such a way, go back to the code when we wrote stack by using arrays. Okay. So let me go somewhere much earlier, somewhere over here, and look at the main function. So this is, look at this main function. Now the current function which I have written, it looks exactly similar. I mean, it initializes the stack. Only thing is I am taking stck underscore ptr. Here I was taking my stack, or I was taking stck over here. I am taking my stack here. That name changes. But otherwise, push is almost exactly similar. Pop is almost similar, or other exactly similar, and likewise. So essentially the same main function. But remember that in this case, our stack was implemented by using array, whereas now we are implementing our stack by using linked list, which means that even if the implementation has to linked list, this function, main function, need not change. And this is what I was mentioning about the utility of abstract data type and use of that information hiding and data hiding and all those things. So what is happening is, the user of my library, and I am the writer of stack library, the user of that library should not change the code just because my implementation changes from array to linked list. And now instead of, so without anyone else changing their code, I can change the implementation of my library, and I can release that library as a dynamically linked library, in which case nothing changes actually. If I release that as a static library, at least one more compilation is required on the user's end. But if I release it as a dynamic library, then in that case not compile the code again, and directly all thought through, we have put wrappers around the structures that we have. The last node of the linked list as the top node. But then in that case, just like in the case, so because I'm used to array, I'm used to go through the complete linked list, which is waste of